so you just have to click away.
Very good. Thank you very much indeed, Sam. Thank you. It's a pleasure to come and talk to you. You can see from my title that this talk is about the unconscious. I mean, I'm aware that this is probably quite a diverse audience, maybe some psychiatry, psychology, genetics, and so on. But we're all interested in the unconscious, aren't we? It's kind of, everybody's got some views on what can and can't happen unconsciously. But I'm going to try and focus not so much on the psychology here, but on the implications of this sort of sorry saga that I'm going to tell you about for the way we do research, for thinking about open science and how we can do things better in the future. So this is work with my sort of long-time collaborator Miguel who's in Madrid. And assuming that most of you are not perhaps particularly familiar with this field, let me just say a couple of things generally. I mean, first of all, research on the unconscious is an industry. It's an enormous industry. And certainly within cognitive psychology, you'll find that a mainstream view would be that much of the things that guide our behaviour do so, at least in part, through some unconscious pathway. That will be any textbook that you open will kind of express that view. And of course that view is incredibly well entrenched in neuroscience as well, cognitive neuroscience, unconscious vision, and so on and so forth. But just think about this. This is a little bit of a caricature, but just think about it this way. How easy or difficult would it be to show that a particular mental operation, mental process, can take place unconsciously? Well, actually, all you need to do is to have a really rubbish instrument for measuring your participants' awareness. Okay? And then you're going to say, oh no, they weren't aware. I didn't detect any awareness of the crucial regularity in my experiment. But I did manage to demonstrate that my participants were affected, by emotional stimuli or whatever. Therefore, it must have been unconscious. And that is, of course, that's a gross caricature, but it's not that gross a caricature. And this issue about, things like using underpowered studies, weak instruments, smoothly gliding from failing to reject the null to accepting the null. All of these things that we're talking about in the sort of open science movement are absolutely rampant in this area. So I hope these sort of points will be illustrated as I go through this particular example. So there's a question for you to kick things off. Was the World Wide Web invented before or after 1979? Before or after? Sorry? So I ask you that question and you say before or after, and then I say to you, in what year was the World Wide Web invented? Anybody know? 1990. Okay, and it's 1989. The point of this is that this is how you get a Nobel Prize. This is the anchoring phenomenon explored by Tversky and Kahneman. And the point is that the number in the first question will bias a little bit the answer that you give to the second question. Extremely well established phenomenon. And the contrast condition would be if I'd said to you beforehand, was the World Wide Web invented before or after 1999? So that would pull your rating a bit later. The first question would pull it a bit earlier. Okay. So that's very well established. What about this example? Okay, so are there any American football fans in the audience? Brilliant sport. Here is an American footballer called Stan Fisher. And your task is to estimate how many sacks Stan Fisher will notch up, tackles basically, in the college final game. Okay? And you look at either the picture on the left and you make your judgment, I think you'll have 15 tackles, or you get the picture on the right. And of course what's being manipulated here is something completely irrelevant, the number on his question is, does that number unconsciously, surreptitiously influence a judgment that you make about something like his performance in the game? And so this project that I'm going to tell you about goes back to this piece of work published by Critcher and Gilovich quite a while ago, 2008 now, in which they did exactly this experiment and claimed that you get this, what they call incidental anchoring effect. So the example that I showed you about the World Wide Web, I mean, it's a bit more deliberative. So remember, the first thing I said to you was the World Wide Web invented before or after 1979? So you're actually consciously thinking about that. And then I ask you a second question, and the influence is from one of those to the second. So there's something a bit deliberative about that procedure. This is much less deliberative. I mean, nobody is drawing your attention to the number. You don't have to make any judgment explicitly about the number. We're just asking whether the presence of that number in the image can affect your judgments. By the way, this is informal. If there's any questions at any point, do shout out. Wave your hand if anything's not clear. So what Critcher and Gilovich did was they reported 3 experiments, and all of these experiments obtained evidence of this sort of subtle, unconscious or incidental influence of a number on a judgment. So that in the first experiment, it was the American football example. The second experiment, participants saw an image of a mobile phone, and the mobile phone had a sort of model number on it, and the model number was either high or low, the Sony Ericsson P17 or the Sony Ericsson P97, completely incidental to the subject's task, which was to estimate the percentage of sales of that mobile phone that would be in the United States versus Europe. It's a completely weird judgment that people had to make. They'd come up with some number. But Critcher and Gilovich claimed that the judgments that they made on average were a little bit influenced by the model number. Does that make sense? And the third one is the one that I'm going to focus a bit more on, is how much would you be willing to pay for a meal in a restaurant? And I'm sort of a bit more interested in this, I think, because this is slightly more consequential. How much would somebody actually pay for a product or a consumption experience? If you can show that you can tweak that by little irrelevant signals in the setting, I mean, that would be quite interesting and quite important. So they did, their third experiment was like this. Here's Studio 17 in Butler, Pennsylvania. Studio 17 is a new restaurant set to open. Imagine that you're going to dine at this restaurant, estimate how much your bill would amount to. And what Critcher and Gilovich claimed again is that the amount that people expressed there for the cost of a meal in the restaurant would be slightly affected by the number in the name of the restaurant, whether it's 17 or 97. Okay. So that's just one published article from about 10 years ago. There haven't been many follow-up experiments, which in itself might be indicative. You know, maybe there are some filing cabinets somewhere with some failures to get this effect. But there have been a couple of papers subsequently. This Turkish group, whose names I'm going to struggle to pronounce, Dogaliolu, Demir, and Kochas, something like that. They've published 2 papers on this. So this was the first one from 2015. And what they've done is they've looked at this restaurant version, and they've done various tweaks to that experiment, but they basically replicated the standard experiment. And so we can put 2 of their experiments into a little random effects meta-analysis and look at the overall size of the effect. And so let me just pause here and say, I mean, one of the things that I've become convinced about over the last few years is that meta-analysis is a really crucial part of the new toolkit, if you like, that's available to us for looking at So these are restaurant studies. I'm focusing here on this restaurant situation. We've got 3 experiments, the original Critcher and Gilovich one. You'll know how to read this figure. Yeah, and it's just showing the effect size from each study. Here, that's the effect size as a Cohen's D and the confidence interval on that. And this is the meta-analytic effect size, which is about 0.5. So it's not a modest effect, 0.5. Okay, well, we got interested in this phenomenon for a number of reasons, and started to sort of have a think about some of these findings and how robust and reproducible they were. And that Turkish group shared their data set with us, which was good of them. And it's pretty obvious that this effect is fairly fragile here. I mean, the sample sizes are very small in these experiments. And that's a box plot of the data. And, you just, a tiny decision that you might make about treatment of outliers would change the result from an anchoring effect to a null effect. It doesn't even become significant one-tailed if you remove these outliers. And similarly, we got hold of Critcher and Gilovich's data, and again, they said nothing about treating outliers, but you get outliers, particularly in the high anchor condition. The results are very fragile to these decisions that you might make about how to treat outliers. Now, even worse than that, this is the second paper by this Turkish group, which is still in press in the Journal of Business Research. And again, it included a replication of this restaurant phenomenon. And when I read this, I thought, there was some really obvious issues here. I mean, this is I don't know if this is being recorded. This is an email I think, in retrospect, a polite email that I sent back to the author, saying, I think there must be an error in your data, so you can't read this right. I'll read it out. So this is a quote from their paper. We found significant differences in WTP willingness to pay. For a meal at Studio 17 versus Studio 97, mean equals that, mean equals that. T 57 equals minus 0.26. P is less than 0.01. I would hope that even a first-year undergrad would look at that and think, hang on. So it's just really bizarre errors that you would think anybody would pick up in a paper. But when I looked at it a bit more, I became even more concerned. And I actually now think this paper has to be retracted, which is something that I will be taking up with the journal in due course, I think. The problem here is that there's really unacceptable reporting of the data that they've collected and the experiments that they've run. So let me just quote again from my, I think, reasonably polite email. I've noticed something else that seems quite worrying. In study 1 of your 2015 marketing letters article, you have 4 conditions. Low condition Studio 17, high condition Studio 97, crossed with 2 question types. How much would you be willing to pay for your own meal? How much would you be willing to pay for a hamburger meal? Okay, so there's a 2x2 design. If you then look at study 1A of this later, this in-press paper, Journal of Business Research, it reports an experiment which also has 4 conditions, but in this case, the conditions ask participants how much would they be willing to pay for a meal at Studio 17, Studio 97, Studio 099, or Studio 1999. So, I mean, the point is that these are described and written up as 2 But when you look at, they have a common pair of conditions, just, but standard Studio 17, standard Studio 97. And it's clear that this is the same experiment, the same data. The means are identical across these two reports of what appear at face value to be completely different experiments. I mean, and they're described as different experiments because the other two conditions are indeed different between them. So somehow or other, what they've done and what they've reported are quite wildly divergent. And I got a reply back from them saying our JBR paper is based on our ML paper, blah, blah, blah. Through rounds of reviews, study one evolved into its current version. The reviewers, persuaded us to rewrite it all in a different way. I mean, this is really not what you would call transparent research practice, I think. So, of course, we then put all that aside and have our own go at doing this experiment. So I'll tell you about 3 experiments that we've done. I mean, they're all, these are all pretty simple experiments. We progressively improve on the methodology to be, more and more convincing about the conclusions that we can draw. So in this experiment, we actually asked people not just about the restaurant, but also about a whole load of other kind of judgments that they would make about consumer choices. So, for example, how much would you be willing to pay for this snazzy set of VR goggles? So you can see all the questions there and the images that were used with them. And of course you've got the anchors here, a high anchor and a low anchor for each of these items. And we just thought this was a reasonably broad set of sort of questions and items to look for any anchoring effects. I should say we always gave people the restaurant question first, because that was the one that we were particularly interested in sort of seeing whether we could replicate that. And then the other ones come later. And this is done within subject, so each person gets a high anchor version of one and a low anchor version of another, and so on. And we look at the judgments that people make. And to cut a long story short, so there's a ton of data here, but there's no evidence of any anchoring effect. So you've got the different items here, with the restaurant being the sort of replication. Here are the mean judgments that people give, and the Cohen's effect size, and you can see that the effect sizes all vary a little bit, but around 0, none of these is significant, with the possible exception of this one here, the iPad seems to show a bit of an anchoring effect. But you'll see in the next experiment that doesn't replicate. So we thought, well, that's not very encouraging, but it turned out in retrospect the way we had asked the question was a little bit different from how those previous experiments had done it. So what you can see here is in the second study that we've done, what the participants are told is the following. So they get this bit of text that says Studio 17, Studio 97 is a new restaurant, di-da-di-da-di-da. So the question, which asks them to make a judgment, actually restates the number. Okay, so they do get the number not only in the image, but also here in the text. And so we ought to just check that, that maybe that's crucial. So we change the question here so that the number gets mentioned in each of these questions that the participants answer. It doesn't really make any difference. Again, if you sort of glance down this column of the effect sizes, you'll see that they're all very close to 0, and none of these is significant. Now we were, at this point, with quite a few null results, we were thinking. Yeah.
Sorry, I was just wondering, those earlier studies with the NFL player?
Yeah.
Isn't that where they saw that effect? Isn't that because that's more about random guessing, like no one knows? Whereas
question that you're asked is this slightly odd question. What percentage of sales of this mobile phone will be in the US versus Europe? Now, I presume you would say that that's, I mean, people are guessing there, right? So what I can say is that in one of the big reproducibility projects, they tried doing that experiment and they weren't able to replicate that. I mean, with a huge sample size and multi-lab thing. So I mean, you're absolutely right. It may be that there's something different about a judgment, about a meal in a restaurant, the sort of thing that we have lots of experience of doing, versus something random which we have no experience of doing. I'm concentrating on the restaurant one, because I think this is quite important about consumer decision making. But I take the point that that doesn't mean that you wouldn't get the effect if you go and look at that sort of American football example. Does that answer the question? Yeah.
David, I do have a question. For the membership and iPad, those were significant both times, but I noticed that there's a Bayes factor. So are you basing the fact that they're not significant on the Bayes factor? Or?
No, I think they go the other way, don't they?
Yeah, they do.
Yeah. They go the opposite way.
Yeah, it's just that at face value, they are significant.
They do come out significant. Yeah. I mean, they wouldn't survive a bond-friendly correction.
Yeah. Oh, I see.
All right.
Okay.
And the next one is pre-registered.
Okay.
So then, in your third experiment, this is actually now absolutely identical to what Critcher and Gilovich did. Critcher and Gilovich were kind enough to send us actually the image that they used and the exact wording and everything, so we were able to do this precisely. And what you've probably noticed, so here's the restaurant picture. So it's an outdoor picture of a restaurant and it says Studio 17 on it. Obviously this is photoshopped. In actual fact, what Critcher and Gilovich did was they used an interior image. This is their interior. They used an interior image. And actually there isn't a number anywhere in the image at all. The number was only mentioned in a kind of caption next to the image. So we did it exactly the same way. We didn't actually use the same image because their restaurant picture, I mean, it's just a marvellous kind of 1970s restaurant interior. This is sort of fractionally more contemporary. But just take it from me that we've just done everything we can to tweak really tiny aspects of the protocol to get it as similar as possible to what Critcher and Gilovich did. And the other key thing here is that this is now all pre-registered. These are done as online experiments, so we're recruiting participants through NTurk, so we're getting, and we sample an American population of participants, which is what Critcher and Gilovich did. And there's a huge sample here. There's nearly 900 participants in this experiment. Okay, so the restaurant study here shows no effect whatsoever. You get a Cohen's d of minus 0.01. Now, we were a bit worried in these experiments. This is the second experiment. We were a bit worried that we're getting all these null results. So we thought, well, actually, wouldn't it be sensible to just build into our experiment a standard anchoring question, like the one that I asked you right at the outset about the World Wide Web, just to show that we're capable of, these experimental procedures are capable of obtaining these standard anchoring effects. And that's what's shown in the bottom two rows here. So these two questions are like the World Wide Web question. The population one is, I think, is the population of Chicago greater or less than a number X, which is the anchor. What is the population of Chicago? And so people's estimate is about 3.4 million where they have a high anchor and 2.5 million when they have a low anchor. And the length is the length of the Mississippi River, again with a higher or low anchor. But the important thing to emphasize here is that this is This is a more deliberative sort of setting. It involves two questions. Is the length of the Mississippi River greater or shorter than 100 miles? The participant thinks about that question and answers it, and then immediately gets the question, how long is the Mississippi River? And so you can see here, you get a massively robust standard anchoring effect in these experiments. And in the pre-registered experiment here, we in fact had 4 different standard anchoring things: population, birth rate, distance, and year. So the year one is the World Wide Web one. And when you say to people, was the World Wide Web invented before or after 1999? And then you ask them when it was invented. Their average is 1988. When you say to them, was the World Wide Web invented before or after 1979? When was the World Wide Web invented? They say 1984. Okay, so there's a 4-year difference in the average judgment that people make about this. It's a really, anchoring is itself a fascinating topic, but there's no doubt that under those standard conventional anchoring conditions, you can get a whoppingly robust anchoring effect. And just to convince you that the distribution of scores for the incidental question, there is no effect of the anchor. This is overlaying the two distributions. There's really no effect of the anchor whatsoever. Okay. So just for the last few minutes, I want to come back to meta-analysis. And I mentioned before how important I think meta-analysis is here. Because you can always look at these things and say, well, you've got a null result, somebody else gets a positive result. Somebody's positive result contradicts my failed replication just as much as my failed replication contradicts their earlier finding. And the fact that one study is done temporally first is neither here nor there. But meta-analysis really allows us to ask questions about what conclusions should we draw when we aggregate all of the data. That's the critical thing. And so I'll show you just some of the meta-analytic results that you see when you look at different samples of these data sets. So this is, at the top here, this is what I've already shown you. These are the published restaurant studies showing an overall anchoring effect of about 5. The second block in red, these are all the incidental ones in our experiments that I've just shown you, including the restaurant, the final pre-registered experiment, the restaurant one, which got a negligible effect there. And obviously you can see overall there's no meta-analytic effect at all in our sample of incidental anchoring studies. If you look at the standard anchoring, the sort of classic 2-step anchoring conditions that we ran in all these experiments, you get an overall strong effect. The effect size is about 0.8, so it's a really, really big and clear effect in these experiments. And then lastly, you can look at what happens when you pool all the data, what happens when you have the original studies, the published studies, plus all our incidental ones, and what happens when you look just at the restaurant ones, for example. And so if you just look at the restaurant ones here, which I've tried to emphasize that this restaurant example is the one that we were really interested in, you find that the effect has an average effect size of 0.22, but it's actually not quite significant because the confidence interval touches 0. So you might look at that and think, well, okay, I mean, you've obviously when you pool all the data, you dilute the effect. But even with this huge sample size in the final experiment, you still end up with a pattern that looks pretty suggestive of an effect, doesn't it? So that's where I think you have to look at the other key element of meta-analysis, which is looking at what meta-analysis can tell us about publication bias and researcher degrees of freedom and questionable research practices and so on. Because what we can now do is to produce a funnel plot of these data. And so many of you, I'm sure, will know how to read a funnel plot. Yeah, I mean, just in case some of you not so familiar with this. What a funnel plot is doing is it's showing on the x-axis the effect size from the study, and on the y-axis it's showing just a measure of the variability that you measure from that study. And you can think about this really as sample size. It's a standard error, but basically it's reverse plotted, because as the sample size goes up, the standard error goes down. So just think about this as being a study with a huge sample size, and down here a study with a very small sample size. And each of the markers here is a particular study. So these red squares are all the incidental studies from our experiments. The green ones here are the 3 previously published restaurant studies. And up here are our classic anchoring effects, the ones that I'm saying are real, they're real effects. And the reason for plotting this sort of distribution in this way is that you can see whether these two things are related or not, because as long as one is willing to make some reasonably logical assumptions, there should not really be any relationship between these two things. I mean, the size of the effect you obtain in an experiment shouldn't be systematically related to the sample size in your experiment. Of course, as your sample size gets bigger and bigger and bigger, the precision of your effect size estimate should get better. And that's why you have a funnel here, because what you expect is that the distribution of effect sizes that you would obtain if you did the experiment repeatedly with a very large sample size will be much smaller than the distribution you would expect if you have a much smaller size. So this funnel shows, so what you should be expecting in this distribution is symmetry in the data. And clearly what you can see here is that they're absolutely not symmetrical. In fact, these two variables are significantly related. So inside the grey area corresponds to all the points where the effect would not be statistically significant. And you just look at the 3 round points there. Is it just an accident that they just happen to fall outside that grey area, just conveniently outside that grey area? No, I don't think it's an accident. What's going on here is some combination of publication bias and the use of questionable research practices. So I speculate that either one of the following 2 things has happened. Either there are lots of, or some combination of these 2 things, lots of filing cabinets with lots of experiments which never got published, but if we could find them, we would see that they all fall down here. So that the funnel plot would end up being symmetrical. Or, take this data point here. The real value of that data point is not here, it's over here somewhere. It's inside the grey area. But by the use of a questionable research practice, the researchers have managed to nudge it over here. How do you do that? I mean, you do that by, for example, peeking at the data, finding that it's nearly significant, it's here, let's say, and topping up the sample size. And if you do that enough times, you're guaranteed to get to statistical significance. Or you've used some data transformation or some exclusion rule or something that just nudges the data point across this critical boundary. So there is clearly something in the literature that is not healthy. And you can see that, so this is my final slide, you can see that if you do a P-curve. So some of you familiar with you've looked at P-curve? So this is just a method that says, well, what happens if we look at the p-values that we get in the published studies? So these are the published all the previously published, sorry, this is all of the studies on the restaurant effect, including our own ones. If an effect is genuine, you know, and you have enough studies looking at that effect, then you should have more results that are significant at less than 0.01 than are significant, say, at just less than 0.03. So this curve should look like that. With a real effect, you should have a lot more very small p-values than slightly larger p-values. This is the curve that you get. This is completely the wrong shape. I mean, it should be higher here and then come down. In fact, you know, and the conclusion is that probably the distribution of p-values is virtually exactly what you would expect if there's no true effect at all. So incidental anchoring is not only very difficult to replicate on its own merits, I would argue, but you also, when you go back and look at the prior literature, you see some concerns over transparency. And this story is playing out, isn't it, in so many different areas now of our research. This is just one of dozens and dozens and dozens of examples that you could give of places where something is proved to be hard to replicate. And you go back and look at the past literature and see that there's something pathological about it. I haven't really talked specifically about social priming, but if you're familiar with the social priming sort of phenomenon or literature which played such a big role in psychology in kicking off this reproducibility crisis, you can see that, you know, the social priming effects are extremely similar to what we're looking at here. And I think, you know, that partly the uncritical acceptance of this research is just because we have a zeitgeist at the moment which is extraordinarily accepting of any claims about the unconscious. And that is a large part of the problem. In reality, personally, I think there's very little that goes on in the brain that's unconscious that's interesting, really. But so we need to sort of stand back and think, not only, you know, look at the data and what the data tell us, but also think about kind of, you know, the meta-theoretical, the framework that we're bringing with us when we come to a research topic. And if that framework is sort of inviting us to adopt a confirmation bias, then it's not surprising that we end up with faulty conclusions. Thanks. Very happy to take any questions.
Anyone have any questions? Sure, there's a question. Yeah?
I think there's a recent paper published by UCL clinical trial unit commenting on meta-analysis versus individual patient data analysis.
Right.
And I think the paper suggested there might be some bias, like I think it was like 10% bias towards the intended effect to be tested in meta-analysis, given that the studies included weren't like properly powered, like individually.
Right. Is this the paper that's in Nature Human Behavior?
Yes, I think so.
I'm not sure it had a UCL connection to it.
Oh, it's not.
Oh, maybe it did. Yeah, I know what you mean. Yeah. So it's interesting. Yes, it claims that. I mean, I think it claims that meta-analyses overestimate an effect size compared to pre-registered studies. I'm not completely convinced by that, but I don't think that really speaks to. I mean, I don't think that challenges the conclusion here, because I'm saying that the meta-analytic effect size is zero, really. So let me just amplify a little bit on why I wasn't terribly persuaded by that paper, because actually anchoring, this very phenomenon, incidental anchoring, is one of the scenarios that's included in that study. What said that incidental anchoring is a real thing in this multi-lab project. The problem is that the meta-analysis that went into that analysis, it's not published, it was done as part of a master's thesis. And I think, when I've looked at it, I've actually read it, I mean, its selection criteria was very strange. So I'm not sure I have an awful lot of confidence in the conclusions of it.
What do you think should happen when a scientist who is into this unconscious stuff publishes a popular book? I'm thinking of John Barnes from a couple of years ago.
Yeah.
A couple of years ago, so well after all the replication crisis happened, which didn't mention the replication crisis at all, and put forward a whole thesis that unconscious cognition was what underlies basically all our behaviour. What do you think can be done about that sort of thing?
Well, I'm not sure we can do anything in retrospect, but other than what really Shimak did, I don't know if you've seen his book review. So this is a blog. So for those of you who don't know, so Barge is one of the the key people who contributed to this sort of social priming work, and there's enormous range of question marks over many of the studies that he's published, many of which have explicitly not turned out to be replicable. His book, just never mentions any of this. But what happened was that there was then an online book review written, in which Shimak went through it chapter by chapter and said, all right, in chapter 4, Barge talks about the following 6 experiments. Here's my P-curve or my meta-analysis of those 6 experiments, and they show A, rampant publication bias, B, and so on. And it just goes through the whole book, showing that the quality of the evidence that's being reviewed is absolutely non-existent. So
The problem being, though, that of course the book was a
more people
bestseller, and
are going to
that's
read the book, but ultimately you have to just trust readers to make their minds up and look at it. But yeah, that's a pretty sorry state of affairs. I agree.
So in the kind of restaurant studies, the prime is conscious. You can see it's studio 7B.
Yeah.
And the answer is also conscious.
Yeah.
It's $20.
Yeah.
The unconscious part is the kind of black box in between. But I was wondering if the prime is the studio 7B, if that was unconscious, so subliminal priming experiments. Do you think that there would be more? Would there be incidental anchoring in this case?
Right. No, that's a nice question. So there are about 3 or 4 published papers trying to look at subliminal anchoring, and guess what? They turn out to be very inconclusive. I mean, they have tiny sample sizes, etc., etc. So but I think somebody should go back and pick that up, have a look at that effect under high-powered conditions, and it might turn out to be a real thing. But as yet, the evidence I think of subliminal effect is pretty patchy. But I would say the same thing about this is anybody here who does research on subliminal priming, and I don't believe any of it really, because it's all underpowered. Incredibly underpowered. And as I said right at the outset, you do a subliminal priming experiment. Well, how difficult is it to show that your participants might be unaware of a prime? It's incredibly easy to do. Yeah.
May I ask you the second question?
Yeah.
So I find it very interesting. So as far as I understood it, if you say something like the Mississippi, you do get this anchoring effect.
Yeah.
So it's very variable. You say the Mississippi is it longer or shorter than
Yeah.
the Rogers? I mean, and then you get the priming when you say how long is it?
Yeah.
That's all variable.
sort of standard anchoring, the procedure, the materials are a bit different than in these incidental ones.
Yeah.
And quite regardless of the sort of debates about reproducibility, you'd like to bring them a bit closer together so we can try and pin down exactly what is it that gets you a whopping big anchoring effect in one situation and apparently not very much of an anchoring effect in another situation. So that point is really well taken, and we're going to try and devise some versions which make them much more superficially similar, like the one you say where it's all done in text.
I think the results almost suggest that advertising doesn't work, but it probably does work because it spends so much on it.
Yeah.
So I just wondered that.
Yeah, I mean, personally, my feeling is that, I mean, let me just try this on you and you can tell me whether you think it sounds sensible. I mean, I think the reason that this works is because when you think about the number there, 1979 or 1999, you're actually thinking about it in the sense that's relevant to the estimation question that you're going to do. When you're thinking about that number, 1979, as a year. In the incidental case, when you're looking at the number on the American footballer's jersey, you're not thinking about, if you're thinking about that number at all, it's very unlikely that you're thinking about it as saying something about how many tackles he's going to make. So that's my feeling, is that you have to deliberately engage with the number as a number on the dimension that you're focusing on in order to get an anchoring influence. But that's just a hypothesis.
I found my own defense mechanism when you asked that question. I said, is this a trick? Is it really dead information?
Not a trick. Not a trick. But again, when you see Studio 17, you see that number. I don't think you would normally think of that number to the extent that you think of it at all as saying something about the cost of the meal there.
Hi, thanks for your talk. Is there any way you've amplified a bit further on your views of how uninteresting or interesting the unconscious is? You just kind of touched on it here.
Yeah.
But clearly, I get the sense you have quite developed thoughts on this. Is there somewhere where you've written this down? Is this in the neuroscience?
We have, a few years ago, Newell and I wrote a very lengthy review on the whole literature about decision making, which is one of my main interests, and all the claims from a whole sort of raft of different types of bodies of evidence that there are unconscious influences on people's decisions and choices. And we came through that pretty sceptical about the evidence. I mean, I don't want to just dismiss it. I just want to say that, when thinking about the future, there are things that we've learned that we could do the research much better and in a much more convincing way in order to demonstrate these effects. But generally, you know about the Benjamin Levet's sort of procedure. If you go and look at the literature on that, incredibly controversial. I mean, his original claims about that ERP signal being an indicator of the choice that you're going to make ahead of your awareness, that has been hugely re-evaluated by later research, which improves on the methodology. And you can look at all sorts of different areas like that and see that actually the case is much less convincing than you might imagine. So, I think largely people do the things that they do for good reasons. Reasons that they could articulate if you probed them at the time.
I do have a question. Early on in your talk, you said that you would follow up on the journal to. So, how would you navigate that? Stuart did a talk in April last year about his sort of dabbling in trying to correct papers that have errors or questionable findings. What have you done? What do you do? What's your sort of standard procedure?
No, it's very difficult because the journal editor and ask them to find out what has actually gone on with input from the author. I've only had experience of this once before, when, and this is a few years ago, and it was a very unsatisfactory experience where there was, to my mind, absolute unequivocal plagiarism in a published article, plagiarism of something that I've written. And the plagiarizing article had numerous authors, all at different institutions, and basically institution X said to me, oh, well, you know, our member of staff wasn't the person who wrote that, you need to go to institution Y. And I went to institution Y, and you know, I just got sent around all the different universities, and none of them was willing to say, you know, fair dues, our staff member has to take responsibility for that. So we'll see if anything's changed this time.
It was just today, wasn't it, the person who invented copy and paste started?
Yeah.
So it's sort of relevant to okay, well, thank you very much, David. I'll give you another round of applause for working as well. And everyone's welcome to tea and coffee outside on this, of course.
Yeah, you're welcome.
No, it's fun. It's fun. Like everybody else didn't know what you were talking about. Oh, no, I didn't talk to you at lunch. I just yeah, I was just curious.
So, yeah, I'm very interested in
No,
so you can very reliable on how it's all managed.
I told them about this CCN technique. I said, do you know this thing? It's like, oh, there's lovely people. I said, sure. Well, they haven't come down to me, and I'm not sure. It's tomorrow. I was like, I'm not sure if I should. I was like, sure.
Stuart is coming.